solving and graphing inequalities. At least if you don't make it hard, it's going to be easy.
Inequalities.
Don't make it complicated.
So, graph.
So when we had equations, okay, when we had an equation such as x equals 4, we have one specific value that makes the equation true, right? We would solve, and we would get x equals whatever. And so that one value made the equation true. Does that make sense? We'd solve the equation. Here, quick example, since everybody's giving me blank stares. So if we had x plus 5 equals 2, let's say, and I asked you to solve this, what would you do?
-5.
Subtract 5. And then you find out the only number that will make this true is if x is -3, right? If I try any other number, it's not going to be true. It'll be false.
Because -3 plus 5, it's 2.
Because -3 plus 5 is 2. Any other number plus 5 is not going to be 2.
Okay.
Okay? So when we have an equation, we get one answer. Okay? Does that make sense?
When we have it, if we just said that example, we have it.
So that's all we're saying is if we get an answer like this, x equals 4, that's the only one answer. There's one answer, x equals 4, that's it. Okay? With inequalities, inequalities means it's not an equal sign. It's something else. But when we have inequalities, so here are inequalities that we talk about. Greater than. Okay? If I say that my age is greater than Sally's age, my age could be any number bigger than her age, right? Does that make sense?
Yeah.
Okay? Greater than or equal to. Okay? I could say the same thing, but now my age could be the same as hers or greater or bigger. Does that make sense?
Yes.
Okay? So that's what this line underneath means. It includes it's or equal to. So greater than or equal to. Then we have less than. All right? Less than means like lower than or smaller than. Okay? And then less than or equal to. So lower than, smaller, but also equal to. So we're gonna talk about these. The nice thing about this is in almost every situation, we solve these exactly the same way as we do equations. Like, you know, when we just subtracted 5 on both sides, we do the same thing. There's only one or two times where it's different. So I'll talk about that a lot of times tonight. So graph the inequality and give the interval notation for, see if you can read this, look at your paper if you need to. What does this say? X is what compared to 2?
Less than.
X is less than 2. So if we would graph this, here's what I like to see on my graph. I like to see the boundary point, which is 2. Okay, that's just this number right here. Just write it down on your number line. And then, is 2 included? Could I say 2 is less than 2? Does that make sense? No, 2 is not less than 2. So here's what we do, and this will pop up in a second, but we're going to use an open circle to say that boundary point, 2, is not part of our answer. Okay? And then numbers that are less than 2, if you want to put some more numbers here, like 3 and 4, you can. But I don't need to see them. If you want to put them there, that's for you. Which direction are we going to go if we want numbers that are less than 2?
Left.
To the left. Does that make sense? So it's going to go this way. So that's how we draw the picture. Now, how would we write this in interval notation? We haven't done this in interval notation yet.
That was too easy.
What's that?
That was too easy.
So remember interval notation, you got your lower boundary and your upper boundary, right?
Why?
This time we've got an upper boundary, right?
Why?
What's our upper boundary?
3, 4.
No. I mean, according to the dots, what we've written as our answer, where's the boundary? 2. So 2 is our upper boundary. And then we go forever to the left. How do we write that if we go forever to the left?
Ooh, I kind of remember this.
I think we've done it. But like I say, I teach 5 math classes, and then I forget what we've done in which class. Yeah, negative infinity. Because if you keep going, -1, -2, -3, -4, it just keeps more and more negative. Have we done that or not?
No.
Okay. Negative infinity means we're going to go forever to the left. So the infinity thing is new. We haven't done infinity yet. Okay. So the infinity thing is, it means you go forever in a direction. If we go to the left, it's negative infinity. If we go to the right, what do you think it'll be?
Infinity to the right.
Positive infinity.
infinity.
You don't have to write the positive, but it'll be. Okay? And yeah, it's like a sideways 8. Just so you know.
How do we write? 2 0.
Okay. Now,
2 0.
we did interval notation when we did domains, right?
No?
No? We haven't done interval notation at all? Okay, so interval notation is new. Let's talk about interval notation. I was sure we had done this. Okay. So interval notation,
I was confusing it with the other one that has
the absolute value.
The absolute
Okay.
value.
So interval notation, what you do is you write, have we talked about domains and ranges?
No.
That's right, because we've only done lines so far. Okay, got it. Interval notation, what you do is you
There's
just
a
write,
lot of math in your brain.
you just write the endpoints.
I know, I'm like, did I miss all that last week?
No, sorry.
Yeah.
Like I said, I teach 5 math classes and we do some things here and some things there and they overlap and then I don't do other things and whatever. So what happens in interval notation is you write down the endpoints of the interval on the number line that you're talking about. Okay? So for instance, if I was going to go from, let's say, -3 to 7, and these were, let's leave open circles for now because we haven't talked about filled in circles yet.
Open circle.
So these are open circles. And I want to talk about this area in between -3 and 7. I write down my 2 endpoints, which are -3, 7. Those are the 2 endpoints of my interval. And then because they're open circles, we put parentheses on them. Parentheses mean open circles. So that means this one, open circle, because it's, or parentheses, because it's an open circle.
It's more confusing.
Okay? So now, so this is our answer to this example, by the way. It would be this line, and then this is interval notation. Okay? So this goes with this. Now, another example, so this is one example. Another one, let's say that we drew a different line, and it was from 1 to 100. And now, it's a filled in circle. And I'm talking about this stuff in here. Well, what are my boundary points this time?
1
and 100.
1 and 100. So we always put the smaller one first. So 1 goes first and then 100, just like you'd see it on a number line.
How do you call that?
What?
How do you call that?
The circles? Or what are we talking about?
Like parentheses we put in. How do we call that?
This?
Open circle?
Open circle.
This is open circle. This is actually, technically, it's closed circle. So it's filled in. So this is open. This is closed. It just means it's filled in. Okay? Now the difference is this time, when we have the filled in circle, we use brackets. Okay? Yeah.
What are the differences between those?
Okay, and we're going to get to that in a little bit here, but the difference is in this one, -3 is not part of our interval. It's just the boundary, but it's an open circle. There's like a hole there, so it doesn't include the -3 or the 7. Down here, 1 is part of the interval,
I
and
got
so
it.
is 100.
Okay, thank you.
It's like a greater than or equal to.
That would
Or-
be part of it, right?
Yeah,
Because
the filled in
actually
circle.
part
It's actually
of
filled
the-
in there. This is part of the answer.
Because it's greater or equal to.
Right.
Gotcha.
So it's that or equal to makes it closed
Okay.
with a bracket. And we're going to see that actually on the next slide, but we haven't gotten there yet.
Okay.
Okay. Now, here's another example. If we go forever to the left and there's no boundary point to the left, that's where we use a negative infinity.
Okay.
Negative infinity or positive infinity always gets parentheses because there's no like point that we can include, right? It just keeps going forever and ever and ever.
So they have
So
an
these
arrow at the
these
top.
always get parentheses.
So
okay.
the line
And
they have
then
an arrow.
You can also mix and match. It could be that one side is open and the other side is closed. Okay, so we'll do some examples and see that. I'm sorry.
Arrow.
In my mind, I was thinking we had done this already. What?
Is an arrow at the top, right?
The arrow means that it's going forever that way. Okay, so notice that it's an open circle. We use an open circle if the
Open
boundary point is not included in our solution. Remember we said 2 is not less than 2 because 2 is equal to 2, right? So 2 is not part of our solution. So it gets an open circle, and that also means it gets a parentheses. Open circle and parentheses go together.
Open circle and parentheses go together.
And then over here, closed circle
Close circle.
and bracket goes together. Okay, so our next example I think is like that. So let me erase.
So next.
All right, so once again, we're going to graph it first and then interval notation. So graphing, what's our boundary point?
-1.
-1. And then this time, because of the or equal to, that means this is a closed circle. So closed, filled in. Okay, and it's because of the or equal to part. Because -1 does make this true. Now, if we need numbers that are, how do we read this? Greater than or equal to, which side of the -1 do we want to choose? To the right. Like 0 is greater than -1, and 1 is greater than -1, and 100 is greater than -1. And so our arrow just goes forever this direction. Now, so is everybody okay with the picture?
Yes.
So every time you get the equal to, that's gonna be a closed circle?
Yep, exactly. Whether this is a less than or equal to or a greater than or equal to, anytime that or equal to part is on there, it's a filled in circle. Okay, so we're okay with the graph? So let's write it in interval notation. Do we have an upper boundary or a lower boundary point this time?
Low.
We have a lower. We don't have an upper because it goes forever to the right. Does that make sense?
Yes.
Because the arrow just says we go forever that way. So we have a lower boundary point. It's -1. And if we go forever to the right, the forevers are the infinities. And since we're going to the right, that's positive infinity. Now, like I said, infinity isn't a point that we can include, so we always put parentheses on infinities. Anytime there's an infinity, always parentheses.
It doesn't matter that it's
Doesn't matter what the other side does. Infinity
Okay.
always gets parentheses. Then the question is, what goes on this side? Bracket, because it's a closed circle, right? Closed circles go with brackets, and vice versa.
So to put an infinity, we have to look at the line, right?
Yes. You mean the
So
graph
if,
here?
yeah,
Yeah.
if the arrow is left side, you have to put infinity in the left.
You put
If
a
the arrow-
negative infinity on the left. Yep. If it goes to the left, because then you're going in a negative direction.
Is there a reason why every time you put it an infinity, you're supposed to do infinity?
Say that again.
Is there a reason
Parentheses, you
why?
mean?
Yeah.
Yeah.
Sorry.
It's because there's no point that I can stop and say, okay, now we've reached infinity.
Oh, okay.
It doesn't ever stop. It just keeps going forever and ever. So there's no like stop here and include this point. It's just, it keeps going. So that's why it's always parentheses. Okay. Let's try another one. You guys got, it seems like you got the interval notation now pretty quickly. Notice that a closed circle is used on the boundary point if it is included in the solution. So this is part of the solution. And again, closed circles go with brackets. Okay, or equals to, or so the or equal to, closed circle, and brackets all go together. Those three things all go together. If it's a not an or equal to, then it's an open circle and parentheses. Okay. All right, let's see if we can write this one down. So here's a picture, and you can't see the arrow, but it goes forever that way. So let's see if we can write down the inequality as an inequality statement and also interval notation. Okay, and we'll just say x. So let's say this is something x, what can you tell me about x?
5.
What's the boundary point?
3.
3, right? Does that make sense?
Mhm.
So how does x compare to 3?
Equal.
Is it equal to it?
Mm-mm.
How do we know?
Less.
Greater than.
So the first thing I'd say is, depending on which direction it goes, are the numbers bigger than 3 or are the numbers less than 3? Greater than 3 or less than 3?
Greater.
Greater than 3, like 6 is greater than 3, 9 is greater than
Oh.
3, 4 is greater than 3. So what does our greater than sign look like?
Open.
Like this, right? Good. And then how do we know if the or equal to sign goes underneath here?
If the circle's close.
If the circle is open or closed, and this one is
Open.
open, so that means, is there an or equal to?
Mm-mm.
No. So this is our inequality. Now, if we're going to write it in interval notation, we've got a 3, obviously, right? Does a 3 go on the left or on the right?
Left.
On the left, because it's the lower boundary. And then what goes on the right?
Infinity.
Infinity, because it goes forever to the right. And infinity always gets parentheses. Now, what does the 3 get this time? Parentheses, because no or equal to, right? Open circle.
What is that called again? Is that?
What? This one?
Inequality? No,
This one?
Infinity.
The whole thing.
This one. What am I looking at?
What are you?
So what is it two different?
We're writing the inequality.
The bottom is the.
The bottom is what we call interval notation. And this is just, there's actually a technical name for it, but this isn't quite that technical. So we'll just call it, this is just an inequality. In your homework, it'll say how they want you to write it. So okay, they're both actually inequalities. It's just two different ways of writing it. Okay. How about this one?
Will it take both answers on the homework?
It depends on what what it says. Like I said, I think it'll probably tell you which way to write it. Okay, so looking at this one, again, let's talk about x. What's the boundary point?
-4.
-4. And then, since we're going to the left, what sort of symbol should we use? Less than? And do we need the or equal to?
Yes.
No.
Yes.
How do we know?
Because it's
Close.
closer.
Closed circle, so or equal to? Yes. Correct. Okay, so filled in circle or equal to. Then, when we write interval notation,
-4
the -4 goes where?
on the right.
On the right, because it's the upper boundary this time. And then what goes on the left?
The infinity.
Because it goes forever, right? And it's negative infinity.
Will you show the arrow in the test?
Well, I mean, the graph that I have doesn't show an arrow, so I can't. But what happens is, if it's not going this way, you know, it doesn't. I'm not trying to trick you. It just keeps going. So I'll try and make sure there's an arrow on the test if that's going to be confusing. Or you can just ask me, does this go forever this way? And I'll say yes. Okay, infinity always gets parentheses. And the -4, what should that get?
Right.
Why?
Because it's equal to.
It's or equal to, and it's a closed circle. So you're right, bracket. Just because I ask why doesn't mean you're wrong. I just want to make sure you understand why. Okay? So is that making sense so far? Okay. So let's go ahead. And now we get to what we call solving inequalities. And this is where I was saying that all the rules that worked for equations, like adding the same thing to both sides or subtracting the same thing from both sides or multiplying or dividing, all of them except for one work exactly the same way for inequalities that they worked for equations. Okay, so I'm going to run through these just to remind us of these rules. First one is, you've got your A, B, and C. If you've got an inequality, oh, this is the transitive one. Okay, so see if this makes sense to you. If A is less than or equal to B, and then B is less than or equal to C, doesn't it make sense that A would have to be less than or equal to C? So let's see if we can put some numbers to it, or not necessarily numbers, but just a picture. Okay, so let's say that let's say Brenda's age. Brenda, right? Okay, Brenda's age is less than Concha's age. Okay, Concha's age is less than my age. So what does that mean about Brenda's age compared to mine? She's younger than me, right? Because if she's younger than her and she's younger than me, she's got to be younger than me too. Does that make sense? That's the transitive property. Okay, so that's one example. Another one. Now here's where we get to our rules that we use for solving things. If we have an inequality and we add the same value to both sides of the inequality is still true, right? So let's see if we can picture this. You got a teeter-totter, right? Does that make sense? You guys know what teeter-totters are? They don't even have them on playgrounds anymore because they're probably too dangerous. But a teeter-totter is, you got this thing in the middle and then the people go up and down.
Seesaw.
A seesaw? Yep. Okay. So let's say that I'm on one side of the teeter-totter and my son is on the other side. I'm bigger than my son, so what happens to the teeter-totter? My side is down, right? So my weight is greater than his weight. Okay? What if you give each of us a 50-pound weight? My weight plus the 50 pounds is still going to be more than his weight plus the 50 pounds, right? So if we add the same value to both sides of the teeter-totter, the same weight, it doesn't change the inequality. Does that make sense?
Yes.
Okay? So we can add the same thing to both sides of the equation, the inequality, to cancel things out, just like we did with equations. Okay? Now, subtraction. Does it make sense if we're like this, because we're holding the weights, and you take the weights away, what's going to happen? It's still going to stay the same. So you can take away the same amount from both sides of the inequality without changing the inequality. Okay, so not only does addition still work, but subtraction still works. Doesn't change the inequality. Here's where we have to be careful. There are two different cases for multiplication. If we multiply by a positive number, the inequality does not change. But if we multiply by a negative number, then the inequality changes. And a very simple example of this, let's just make it really easy. 5 is, let's see, we're using less than. Okay, so let me write 1 is less than 5. Everyone's okay with that, right? That's a true statement. If I multiply this side by 2 and this side by 2, and that's positive, it'd be 2 is less than 10. And is everybody still okay with that? Right? So multiplying by a positive number, the inequality does not change. But now let's look at this. If I have 1 is less than 5 and I multiply by a negative 2 and a negative 2 here, what does this number become? Negative 2. And then what does this number become? Negative 10. Now, it may not be obvious right away, but think about a number line. Here's 0. Here's negative 2. Here's negative 10. Negative 10 is less than negative 2, right? So notice what happened. This changed to that. And that's the one time we have to be careful, is if we're multiplying, I guess, or dividing by a negative number. Okay? And I will ask that just about every time. Do we have to switch the sign? Do we have to switch the sign? Do we have to switch the sign? And the only time we have to switch the sign is multiplying or dividing by a negative number. Probably. Okay? So, and the rule for division is the same thing. Positive, nothing changes. Negative, you've got to switch it. Because multiplying and dividing go together, right? Okay? So let's take a look. Were you writing something down? I just heard a gasp, so I wasn't sure if we were writing something down and I went too fast. So let's take a look. Here's our inequality. Our goal, just like when we were solving equations, is to get the x by itself, or the variable by itself. So I'm going to rewrite this right here in the middle. 5 minus 2x is greater than or equal to 11. And if we're trying to get this x by itself, what do we want to get rid of first? The 5. How do we get rid of the 5? Subtract 5 on this side and subtract 5 on this side. So this cancels out. This is negative 2x. This is a 6. Do we have to switch the sign when we subtract? right?
Yeah.
That's like the teeter-totter taking away the weights, right? Doesn't change anything. So no, we do not have to switch the sign. What else do we have to do now to get the x by itself?
Divide and -2.
Divide by -2. So this cancels. We have x. This becomes -3. Do we have to switch the sign?
Yes.
Yes. And the reason we have to switch the sign is because of this right here. We divided both sides of this equation by a negative number. And when we divide both sides of the equation by a negative number, we have to switch that sign. So instead of greater than or equal to, it's going to say less than or equal to.
Only by a negative number?
Only by a negative.
Negative only
So-
for divided and.
Multiplying or dividing by a negative number, you have to switch the sign.
If it, okay.
Not if the answer is negative, if you divide or
It's
multiply
the
by a negative.
sign.
It's what you're dividing by or what you're multiplying by. Now, we've got our inequality, right? This says x is less than or equal to -3. If we want to draw a picture, what does that look like? Our boundary is at -3, right? What sort of circle will go there? Closed, you're correct. And then what direction? If it's less than, goes to the left, that's correct. Okay, and then how would we write this in interval notation?
Infinity.
And since it's to the left, it's negative infinity up until
Minus
-3. Infinity always gets parentheses. And then what will this one get?
bracket.
Bracket, because it's a filled in circle.
Oh my. A lot of steps.
We got to make Sally at least, nervous.
Sally, you're making Sally nervous?
Just Sally.
Okay.
The other people are good. Yeah.
They're all good.
They're all good.
Okay, just remember, the steps are exactly the same as what we did when we were solving normal equations. Okay, so we're going to get more practice with solving equations.
It's easy.
The only difference is if we multiply or divide by a negative. Okay,
It's
oh,
a
here's an
lot
ugly
of
one.
things, Not just a picture.
Okay, now, again, just like equations, so this looks bad, right?
Mhm.
So what did we do when we saw equations like this?
You multiply first.
We simplify each side first, because we should always be able to turn it into like an x and a number and then an x and a number if we need to. So let's start with this side. What should we do first on this side to begin simplifying?
Multiply.
Distribute, yeah, multiply. So this will be 6x minus 12 plus 4x. And let's just keep simplifying this side first, and then we'll work with that side.
Okay.
Okay? So what else should we do after that?
-4x.
Nope. Because we're just simplifying. We're just combining what's already together.
You're adding 4 to 12.
We're just
6
gonna
plus 4.
combine the like terms, right? They're both x's,
Oh.
so we
Yeah.
just put them together. And what do we get?
10x.
10x
Yes.
minus 12. Okay, so we just simplified the left, and it looks like this now. Now there's only two pieces to it, so that's much nicer.
Mhm.
Now we're going to go to the right. What do we have to do on the right? It's going to be pretty similar.
Distribute.
Distribute.
I
So
can't ever say that word.
distribute.
Me neither. and I
Believe me,
said
there are a lot of really fun words that I get to try and say, and half the time I can't say them. What's the one? Like today I was saying something I can never say. Denominator. Denominator is a rough one for me. If I say it too fast, then it turns into something else. That doesn't make any sense. Okay, but are we okay with this? We distribute this and then combine like terms. What can we combine over here?
-20 plus
Yeah, these two. So 12x, and then this is going to be -20. Okay, so now we have x's on both sides. Now, a little hint. With equations, it didn't matter, but I'm going to suggest a little bit differently this time. I would say you always want to put your x on the left-hand side. Okay, it's just easier to work with the x on the left-hand side. So instead of what we might normally do, subtract the 10x, we're just going to subtract the 12x to cancel this out. Because we don't want any x's over on the right. We're going to cancel them out. And what do we get here then?
2x.
And it's going to be -2x
Mhm.
minus 12 is less than, I should have asked. We're subtracting, so simplify, simplify, you don't have to change the signs, right?
Mhm.
Subtracting the same thing from both sides,
You
you don't simplify the signs, or you don't change the signs, I should say. You don't simplify the signs either. So what do we have to do next?
And
Plus 20.
Add,
12, sorry.
we're trying to get this by itself, so add 12. If we add 12 to both sides, do we have to change the signs?
No.
No, so this is gonna be -8, and that's still less than. And then what's the last step that we have to do to get this x by itself?
Divide by
Divide by -2. And this gives us x, and this gives us 4. And do we have to change the signs?
Yes.
Yes, because why?
Subtracting those signs.
We're dividing.
Dividing
Oh,
by a negative. Again, it doesn't have anything to do with the fact that the answer ends up being positive. It's what are we dividing by? If you divide by a negative, you have to switch the sign. And so that becomes greater than. Okay. Again, if we want to draw a picture, where's our boundary?
4.
4. What type of circle is this?
Open.
Does that make sense? Open because there's no equal sign. And then what direction do we go?
To the right.
To the right. And if we want to write this in interval notation,
4.
4 is the lower boundary, and then it goes forever to the right. So that's going to be
Infinity.
infinity. Infinities always get parentheses. And what does the 4 get this time?
Parentheses.
Also parentheses.
Because it's an open circle.
Okay, yeah, open circle. So just remember
So,
that these two are saying the same thing just in a different way. And actually this one, these are all saying the same thing just in different ways. One is saying it with a picture, one is saying it in interval notation, and the other one's saying it just as a straight inequality. Question?
so if it is like the x always should be on the left.
I would
Can we
suggest,
put-
yes.
Can we put x on the right?
It could be. If I would write this same thing with x on the right, here's why it can be confusing. This is what it would say. So this, x is greater than 4, and this, 4 is less than x. That means the same thing.
So
Right.
you have to flip over x.
So what happens is this becomes confusing because people a lot of times look at this arrow and they say, oh, it's going to the right and my arrow goes to the right. And that's true. It always works that way as long as the x is first. Okay? It's like saying my age is greater than yours, but your age is less than mine, right? When you switch the order, you have to change the inequality sign. So I would say it's much easier just to always put your variable on the left, because that's usually how we say it. We usually say x is greater than 4. We don't say 4 is less than x. Okay. Now, again, it means the same thing, so you can do it, but I'm going to guess that probably almost all the time the computer on the homework will have the x first and the number second. Okay.
It's gonna be a fun test.
Any questions on that? Think so? We'll see.